Hi folks, welcome back to Math with Captain Rod. I'm making this video here to help demonstrate or to help you with solving quadratics by taking square roots. So we're going to look at the following examples. We're going to look at numbers 12, 20, and 26. These are on page 275 in your algebra text. Starting with number 12. All right, so the equation x squared minus 9 equals 0. So again, there's multiple ways to solve these. You know, we could factor it, and again, I did that on another video. And you could also apply what's called the quadratic formula, and I'm going to save that one again for another video. But the other method is just kind of by directly solving for x. So if I add 9 to both sides, this is now going to read x squared equals 9. We now can get rid of the square by taking the square root of both sides. I'm going to write this in a new line here. So if we take x squared equals 9 and then we square root both sides. Now the square root of x squared is x. The square root of 9 is 3. Now you'll notice that right now I've just got plus 3. That's called the principal square root. However, look at this equation here. If x squared is equal to 9, you'll notice that 3 squared is equal to 9, but also notice that negative 3 squared is equal to 9. So minus 3 also solves this equation. So when we solve these guys, we're going to typically have two solutions: the principal square root or the negative root also solves this. So we're going to end up with two equations, and that's because, again, you can have a positive number squared or a negative number squared equals 9. So this has two solutions, plus 3 or minus 3. Let's going to take a look at this guy right here. So 4 times the quantity, x minus 1, the quantity squared, minus 25 equals 0. Again, there's multiple ways, but I'm going to focus on the square root method. First step would probably be add 25 to both sides. I'm going to go ahead and divide by 4 next. Now, this would be a good time now to take the square root of both sides. We can get rid of this square by doing this. All right, left-hand side, when we take the square root of x minus 1 squared, we're going to get x minus 1. Now, the right-hand side, the square root of 25/4 is 5/2. But very similar to the previous example, you know, the 5/2 is what's called the principal square root. But when you study this equation here, this, in fact, I probably should have done this. Let me write that last line here where we had x minus 1 squared equals 25/4. At this point in the equation, the x minus 1 squared could be 25/4, which means x minus 1 could be 5/2. But it also could be minus 5/2, because if we take minus 5/2 and square it, we would also get 25/4. So, long story short here, get rid of this stuff. When we go from here to here, two possibilities show up. X minus 1 could be 5/2. Or x minus 1 could be minus 5/2, right? Because either of those squared would work in this equation. And then we solve them independently. Here we add 1 to both sides, so x is going to equal 1 plus 5/2, which is 7/2. Common denominator, this would be 2/2, or 2 over 2. The other possibility is that x is equal to 1 minus 5/2. Which is going to be 2/2, oops, 2/2 minus 5/2, which is minus 3/2. Either of these solutions, 7/2 or minus 3/2, should work in the original equation. I'm pretty confident they will, so I'm just going to go ahead and move on. All right, we'll start working on this guy. I'm going to need a little more room, so I'm going to take this and change its scale and move it over. All right. Now we'll start dealing with this. So first step with this method would be add 50 to both sides. Whoops. Did I copy that one down right? I did. I'm kind of wondering if I copied 20 down right. 4x. I did. They just look pretty similar, but okay. No, looks okay. All right, so first up, let's add 50 to both sides. So we're going to have 4 times x minus 1 squared equals 50. Now, I'm going to go ahead and divide that 4 out. So we have x minus 1 squared equals 50 fourths. Now, again, very important thing to realize. This x minus 1, this, whatever it is, it could have a positive or negative value because by time you square it, you'd end up with a positive 50 fourths. So when we square both sides, we get 2 possibilities. Possibility number 1, x minus 1 equals square root of 50 fourths. Or x minus 1 could equal minus square root of 50 over 4. And we just have to take these one at a time. Now while I'm at it, square root 50 over 4, 50 is not a perfect square, 4 is. This is equal to square root 50 over 2. So when we do this line, I'm going to add the 1 plus root 50 over 2. And again, I could have probably just left that root 50 over 4, would have been fine, but this looks a little bit more simplified. This guy right here, adding 1 to both sides, we're going to have x is equal to 1 minus root 50 over 2. And again, 50 is not a perfect square. That's about all we can do with it. Oh, actually, we can simplify it a little bit more because we can write that 50 as 25 times 2. And the square root of 25 is 5. So we can bring a 5 out in front. 5 root 2 over 2. This one will be 1 minus 5 root 2 over 2. I think I said that wrong back here, but 5 root 2 over 2. So 1 plus 5 root 2 over 2 and 1 minus 5 root 2 over 2 should solve this equation. So I just want to make this video here to help demonstrate how to solve quadratics by taking square roots. I hope that this helps you out with that. Have a great day.